In this video, I'm going to explain how to solve problems using Hess's law. But first, I need to explain the enthalpy change in a reaction. Okay, you know that in chemical reactions or physical changes, we always see that energy is released or absorbed. Enthalpy change is the amount of energy released or absorbed at a constant pressure. If I have a chemical reaction A plus B giving me the product C, and delta H of this reaction is 100 kilojoule per mole, then I want to find delta H of this reaction. If you look at the second reaction, you see actually if I times reaction number 1 by 2, I can get this reaction number 2. So if this one is delta H1, delta H2 actually is 2 times delta H1. So it means 200 kilojoule. And if I have a reaction, C gives me A and B. You see this reaction, if I name it reaction number 3, delta H3, actually reaction number 3 is the flip or reverse of reaction number 1. So the delta H for reaction number 3 is, or reaction number 3 is negative delta H1. So it's equal minus 100 kilojoule. Okay. In addition, something else that we need to know about enthalpy change, if I look at a diagram of energy profile diagram for a reaction, let's say vertical axis is energy, kilojoule per mole, and horizontal one is time in second. If I have a reaction that its reactant energy, let's say reactant, I show reactants what are, and my products are here. You see the energy of products are more than the reactants. And based on the law of conservation of energy, we can't create or destroy energy. So if reactants need to change to this product with more energy, we have to give some energy to this reaction. So the gap or difference, the difference between energy of product and reactant, I write delta H. If energy of product, I show it with H2, and energy of reactant, I show it with H1. Why I'm using H or enthalpy? Because I consider my reaction is at constant pressure. So energy of reactant H1, energy of product H2, and delta H is actually H2 minus H1. That because H2 is larger than H1, so delta H is larger than 0. And this reaction is endothermic. Endothermic. Let's look at one exothermic reaction. So for exothermic reaction, again, here is E, energy, kilojoule per mole. And here we have time second. If this one is our reactant, this one should be our product. Energy of reactant H1, energy of product H2. And the difference between these two is delta H. That is H2 minus H1. And because H2 is less than H1, so it means delta H is smaller than 0. And this reaction actually is exothermic. Right now, let's look at Hess's law. Using Hess's law, we can calculate delta H of an equation using delta H of known equations. But what does it mean? It means if I have delta H for reaction A to B, let's say delta H for this reaction is delta H1. And I have delta H for second reaction, and I name this one delta H2. If I have delta H of both this reaction, and I want to find delta H of reaction A to C, I name this one delta H3. How I can find delta H for this reaction? I have delta H of these two reactions. I want to use Hess's law to find the third one. If you look at reaction number 3, you can see actually reaction just I named this one 1, 2, and 3. I can say reaction number 3 actually is equal to reaction number 1 plus 2. If we want to add reaction number 1 and 2, we need to add reactants together and products together. Let's do it. So A plus B, they are the reactants, give us B plus C. As you can see, we have B in both sides, so we can just cancel these two B together. So the result is A, give us C. So you see, reaction number 1 plus 2 is reaction number 3. So as a result, we can say delta H3 actually is equal delta H1 plus delta H2 as the law of conservation of energy. Let's look at the diagram. As you can see in this diagram, A changed to B. So this one is delta H1. B to C is similar to reaction number 2, so delta H2. And this one is A to C, or similar to reaction number 3. So it's delta H3. And as the law of conservation of energy, we know we can't create energy, we can't destroy it. So delta H3 actually should be equal to delta H1 plus delta H2. Why? Because we have same reactants and same products. So it doesn't matter how we get from reactants to products, the amount of energy released or absorbed should be similar. Right now, let's look at one example. We have 3 equations here, equation number 1, 2, and 3. For equations number 1 and 2, we have delta H of reaction. But equation number 3, we want to use Hess's law to find its delta H. Let's see what's the relationship between these 3 reactions. So if I name this one reaction number 1, this one 2, and this one 3. And as I want to find delta H for reaction number 3, I need to find relationship of this reaction with the other 2 reactions. I look at reaction number 3 and I see I have 2 SO2 in my reactants. I look at reaction number 1 and 2 to find SO2 here. I see I have SO2 in the product of reaction number 2. But here I have only 1 SO2, but in reaction number 3, I need 2 SO2. So I can say I need to flip reaction number 2 and also multiply that by 2. So I do it. So reverse of reaction number 2, and then multiplying that by 2 is 2. And delta H of this new reaction is actually reaction negative as reaction number 2 times 2. Why is negative? Because it's reverse of reaction number 2. And why it's times 2? Because we multiply reaction number 2 by 2. Let's look at this reaction again. Again, when we look at reaction number 3, we see we have SO3 here, 2 SO3. We don't have any SO3 in reaction number 2, but we have 2 SO3 in product of reaction number 1. And we need 2 SO3 in the product of reaction number 3. Just we need to add this one to reaction number 1. So it means if I name this one 4, reaction number 4, we need to add reaction number 1 to reaction number 4 to get reaction number 3. Let's try see if it's correct. So I have this reaction and I want to add reaction number 1 to that. I need to add reactants together and products together. So this one is solid, not gas, solid. So it's 2S solid plus 3O2 gas, and then we add reactants of reaction number 4 to this one. And we add products. And then we simplify this one. For example, we have 2S here, and we have 2S here. We have 2O2 here, 3O2 here, 2 of this one, with 2 of this one. So here left over is 1O2. And then you see we have 2SO2 plus O2, just I rewrite it. O2 gas give us 2SO3 gas. And as you can see, it's reaction number 3. So it means delta H for reaction number 3 should be equal to 2 times minus delta H for reaction 2 plus delta H1, which is equal to 2 times 296.9 plus per mole. Okay. Right now, let's look at the diagram. If we look at this diagram, we see this part is equal delta H1, as you can see in this reaction. This one is equal 2 times delta H2, and this one is delta H3. So as you can see, delta H1 is equal delta H3 plus 2 delta H2. So if we want to find delta H3, definitely we need to deduct 2 delta H2 from delta H1 as the law of conservation of energy says. So we have just, if I want to use this diagram to write it, I say delta H1 should be equal delta H3 plus 2 delta H2. As a result, delta H3 is delta H1 minus 2 delta H2. This is something that we got from adding the equation and using Hess's law. So you see, Hess's law is based on the law of conservation of energy. Let's look at another example. In this example, we have carbon in the form of graphite becomes carbon in the form of diamond, and we don't have delta H for this reaction. And we name this one reaction number 1. And then we have C as form of graphite plus oxygen give us CO2 gas, and we have diamond plus oxygen give us CO2. And we have delta H for both of these reactions. We want to find delta H1. Again, we need to use Hess's law. Okay, let's see how we can find a relationship between these reactions. So if I look at the reaction number 1 that I want to find is delta H, I see I have graphite in my reactants. So I can say reaction number 1 actually is like reaction number 2, and I have one graphite here. I have one graphite here. So I need to use just reaction number 2. In product, I see I have diamond. But in reaction number 3, I have diamond in my reactant, but same coefficient. So I need to reverse reaction number 3. So I can say minus reaction number 3. Or I can say delta H for reaction number 1 should be delta H for reaction number 2 minus delta H for reaction number 3. Let's check this one, see if we are right. So I add reaction number 2 to reverse of reaction number 3. So I write reverse of reaction number 3 is CO2 gas gives us CS in the form of diamond plus O2 gas. Right now, I want to add this reaction, that is the reverse of reaction number 3 to reaction number 2. After that, I simplify that I have one O2 gas this side and one O2 gas the other side. Just these two cancel out. I have one CO2 here and one CO2 here cancel out. And as you can see, the leftover for reactant is C as graphite. And for product, we have C in the form of diamond. So actually, this one is the same as reaction number 1. So because reaction number 1 is reaction number 2 minus reaction number 3. So delta H1 also is delta H2 minus delta H3. Why minus? Because delta H of this reaction, if I name this one 4, delta H4 actually is negative delta H3. Why? Because it's just reversed of reaction number 3. So as a result, delta H1 is equal to negative 393.5. Let's go through one more example. We have 3 reactions again. We have delta H for reaction number 1. We have delta H for reaction number 2, and we want to find delta H for reaction number 3. So again, we need to find the relationship between these 3 reactions. So as I see here, I have 4 Fe in my reactants for reaction number 3. So I write reaction number 3 actually is equal to, I look at for Fe for in reactions number 1 and 2, and I see in reaction number 1, actually I have Fe in my products. But here I need Fe in my reactant. So it means I need to write the reverse of reaction number 1. And also I can see coefficient here is 2, but here is 4. It means I need to reverse reaction number 1 and also multiply its reverse by 2. So it means reaction number 2 is negative of reaction number 1 and also times 2. So it's reaction number 1 negative, it means it's reverse of that, and times 2, it means we need coefficient to be twice of this something that we have in reaction number 1. And then also I can see in my reactant I have 3 oxygen. Okay, I don't have any oxygen in reaction number 1. but I have oxygen in reaction number 2. I need oxygen in my reactants. So in reaction number 2, I see I have oxygen in my reactant, but coefficient here is 3. Here I have 1. So I need to add this one, 3 times reaction number 2. Fe2O3 in products, I have 2 here, and I have Fe2O3 in reaction number 1. So I need the reverse of reaction number 1 and then times that 1 by 2 that we already did that. So let's see if it's correct. So I just reverse reaction number 1 and times it by 2. It means is equal to and as you can see, this is reaction number 4. I name it number 4. That is reaction number 1 times 2 and then reverse. And reaction number 5 is reaction number 2 multiplied by 3. And if I add these two reactions, I get reaction number 3. That I do it now. Right now we have some of these two reactions, 4 and 5, just we simplified that. So we have 6CO this side. So the leftover here is 4 FeS plus 3 O2 gas, give us 2 Fe2O3 solid. That is the same as reaction number 3. As a result, we can say delta H for reaction number 3 is equal to negative 2 delta H1 plus 3 times delta H2. And it's equal to so it's equal this number. Okay, I hope you found this video helpful and thank you for watching.